Hello, and thank you for joining us. Today's webinar is the APS 7450V Automated Sample Prep. Our presenter is Jacob Harrington, Technical Product Line Manager for Teledyne CETAC. We will be taking questions, so please feel free to submit them throughout the presentation. This is being recorded and will be available within a few days. Now I'll turn it over to our presenter, Jacob Harrington.
All right. Thank you, Shelley, for that introduction. And thank you to all of those in attendance. I'm very glad and I'm excited to have the opportunity to present our newest offering from Teledyne CETAC Technologies, the APS 7450V. Before I get into the specifics of the system, I wanted to back off just a little bit and talk about the industry that we're mainly working with. I know for some of you listening or attending, this is information that you're intimately familiar with. You may work with this every day, but for others, it may be still kind of unfamiliar territory. So I wanted to just touch on it briefly. The oils condition monitoring industry, it goes by several names, really. But what it's focused on is understanding the health, kind of the operational health of heavy machinery, in order to prevent breakdown and costly repair. Essentially, the oils condition monitoring, what we're monitoring is data that comes from lubricants and hydraulic fluids that are sampled from these pieces of heavy machinery, from engine, gearboxes, turbines, etc. And one of the key factors that we look for is the metal composition in there. And that's typically determined by ICP optical systems. This metal concentration essentially gives us an indication of how healthy the system is. Samples are normally taken over time, on a regular routine basis, as recommended by either the manufacturer or the service provider. And those samples are used to create a baseline for that specific piece of heavy machinery. Then when metal concentration spikes or is elevated, we're able to use that information to indicate damage or impending breakdown. This allows the owner and operator to make better choices about when and how they'd like to do their preventative maintenance, and hopefully allows them to schedule this sort of maintenance for times where they're not going to cause a delay to a large project. The industry itself, or the testing being done, is done. It's a growing industry, and it's a growing application as more and more different groups are seeing value in having this data. So the sample testing itself, when I say heavy machinery, what I'm talking about is things like bulldozers, excavators, wind turbines. We're also getting into tractors, more agricultural work, trains, planes, high-end RVs, a lot of the transportation industry. It's really something that's been growing across multiple industries as more and more people see the value in the data. Those that are actually doing the analysis are frequently referred to in multiple different ways. Wear metals or wear metals analysis is one of the most common. They're also commonly referred to as in-service laboratories or used oil laboratories. That's all within this condition monitoring industry. So they have kind of several different names within the vernacular, but they're all doing similar work, which is trend analysis, as I mentioned, based off of a series of samples. And this analysis is standardized on ASTM methodology. The method specifically that applies to ICP analysis is ASTM D5185. That's the most commonly used method within these laboratories for ICP analysis. But most of the labs actually follow an adaptation of the method or use it as a guideline, as the ASTM requirements are actually fairly strict. They call for things like sample dilution by weight and running 3 replicates for every sample, which just are not for many of the laboratories who are doing high throughput work and maybe running, in some cases, more than 2,000 samples a day. And one other consideration of that is all of these samples, I mentioned dilution, all the samples require dilution prior to ICP analysis. Typically, they're diluted at a 1:10 ratio. 1:20 is also fairly common, and they're typically diluted in kerosene or a similar solvent, such as white spirit or V-Solve. this dilution step can actually create problems with sample homogenization, but it's critical for the ICP because if you don't dilute these samples prior to trying to introduce them to the ICP, they cause problems with your sample introduction. They can clog up your transfer tubing and certainly your nebulizer and cause issues with the torch. So it's important that you dilute them beforehand. Otherwise, the nature of the samples becomes problematic. So over the last 2 decades, we've seen a trend on the ICP analysis where, especially in ICP optical systems, the analysis times have decreased. This is particularly noticeable with the most recent ICP optical systems from several vendors that are pushing lower and lower and lower analysis times. So the target for a few years now really has been 30 seconds per sample or less. And now we have ICPs that are capable of going even faster than that, driving down to 25 or even 20 seconds per sample, and really trying to get to improve the throughput here. Now, the unfortunate side of that is that while the ICP analysis times have decreased, the sample preparation time has not, and you have to prepare the samples and dilute them before you can put them on the ICP. The APS 1650, which is the Teledyne CETAC product that we've offered for the last 15 years or so, that normally prepares a sample in about 45 seconds for a 1 to 10 dilution. There are other automated options on the market, but they're either similar in throughput or can be prohibitive in both price and size. So this bottleneck is a real problem for many of the laboratories that we'll be talking about. So now that we've established a need for it, I want to introduce the hardware in question. This is the APS 7450V. For some of you, it'll look very familiar. If you know the OIL 7400 stirring or homogenizing autosampler, this is built on the same platform as the OIL 7400. That system has been very well received and was released in the end of 2018. And this uses essentially almost the exact same autosampler, we call the autosampler head. So it uses the same sample width as the OIL 7400, essentially 4 racks across, but it has a deeper sample deck that allows for double the sample capacity. So it can hold up to 8 of your standard Bell Art racks, or a number of different rack configurations. But that means it can hold up to 720 sample positions and potentially dilute 360 samples in one run. So it's got a really good sample capacity, but the fact that we optimized it on depth means that we've tried to minimize the usage of your bench space in terms of width. And that layout was really optimized to try and help laboratories be able to meet their throughput needs while minimizing the bench space usage. In addition to the auto diluter, kind of the module itself, the robot that moves around, we have a syringe pump module that handles all the fluid movements. For this unit, we're actually going with a Cavro. It's a 25 ml syringe and a 3-port switching valve. Now, the Cavro syringes we've used for 15 years, we've used the 10 ml Cavro syringe on the 1650s. And we've seen extraordinarily good performance and longevity out of these syringes. They're easy to disassemble, they're easy to clean, and they tend to be very robust. So we've decided to stick with that vendor that we know has worked well in the past and move to a larger size that allows us to get some speed advantages on this new system. So what are the facts? What are we going to talk about? So we have kind of 5 main points that I want to talk to you about this new system. First is that it's fast, it's affordable, it's capable, it's clean, and it's simple. So let's dive into that. We're going to start with fast. When we did customer interviews, we talked to customers about the needs within this marketplace, within in-service and wear metals laboratories. The #1 thing that we heard is we want a system that is fast and reliable, right? That was kind of our big thing. CETAC automation has always been reliable. From the users who have 1650s, they said, we like it pretty well, it needs to be faster. If you can make it simpler, that's great, but it needs to be faster. So this was one of our main targets with the system. The APS 7450V has a single syringe and a single probe, and with that, it can prepare a rack of 60 samples in under 20 minutes. That's around 19 seconds per sample for a 1 to 10 dilution at 5 mils total volume 8 mils rinse. And that includes sample mixing as part of the dilution step. For reference, the 1650, our previous system, would prepare the same rack of samples in about 45 minutes. And that is a pretty similar dilution, kind of the standard default method of 1 to 10 dilution with 6 mils total volume, 12 mils rinse, so a little bit different. But the new system is a little bit more than twice as fast and includes mixing during dilution rather than after the dilution. Next, affordable. This system has an incredibly low cost of ownership. There's very, very few consumables, and your daily run, all you really need to run the system is your solvent, your samples, and your sample tubes, and that's it. There's no other additional consumables, no hidden costs. Your probe, your tubing, everything on there, your syringe, all of that will last at least a year. The syringe is should last several years based on our testing. So there's not a lot of hidden fees there. The cost of ownership is going to be very, very low. In addition to that, we're offering a very competitive buy price on this system as compared to other systems in the marketplace. The system is capable. So we allow dilution ratios from 1 to 5 up to 1 to 100. Of course, most common for this marketplace will be 1 to 10 and 1 to 20 dilutions. But we do offer that range. That was something that was requested a lot on the 1650 and we couldn't meet. It has good accuracy and it's incredibly reproducible. So all the testing that we've done almost from the very beginning on our development on this system, we've been able to get RSDs under 2% across a wide range of sample types of different gear oils, hydraulic oils, different viscosities. It's been very, very reproducible. And I mentioned it works across a wide range of viscosity. So we've performed testing up to 700 centistokes, which is well beyond your kind of typical oil samples even for your gears. And it does very reproducible work all the way up to that mark. We've had some beta testing going on that even takes it beyond that point and it still performs very well. And then lastly is the sample homogenization or mixing. That's what you see going on the right, this repeating image. What we use is close proximity, high acceleration mixing. And it works extraordinarily well and it's incredibly fast. So what you can see here is we dispense the sample first and then the diluent is added at a very high acceleration. That results in this kind of concussive mixing. And the sample being shown in this video is 600 centistoke oil. Now we've just backlit the tubes and essentially we ran this. This was our very first try. And it came out really beautifully because the system does a very, very good job mixing and it's very reproducible. So why is it so important that we mix? You know, we talked about, I mentioned earlier that you can lead to problems when you've got your sample that's pretty different from your solvent. So this can lead to samples kind of settling over time. That graphic on the left, that's why we talk about the oil 7400. That's why it's important to stir your samples and make sure they're refreshed directly before analysis. It's the best way to ensure that your samples, you don't have any particulate fallout. But I want to talk more about this image on the right. So what that is that's essentially 3 samples. It's all the same exact gear oil that were prepared at a 1 to 10 dilution in kerosene with a total volume of 50 mil. And these samples were prepared in 3 different ways. So one of them was shaken by hand, that's on the far left. One of them was stirred mechanically, and the third we just poured in the oil and poured the kerosene on top. And when I say poured, we weren't being careful to make sure they stayed separated. There was some mixing at the initial, but then as the sample settled out, you can see a very distinct break. So after these were prepared, we allowed them to settle overnight. And in all 3 of them, you can see some settling, certainly. Even the shaken and the stirred, there's definitely some particulate matter there that you can identify in this picture. Again, the photo itself is unretouched. It's just backlit to show exactly where we see the particulate matter. So in both of those, you see some particulate. That's why it's important to make sure that your samples are mixed. Even if you have them well mixed in the first place, you can get some settling. But that sample that's poured is definitely, out of the 3, going to be the problem. And the sort of mixing that you'd normally do prior to sample introduction may not be sufficient for something that's settled to that degree. So it's also important to make sure that you get your samples well mixed when you prepare them, and then also that you refresh them for best quality data. All right. Beyond its capabilities, the system is also clean. Now, at this point, Teledyne CETAC has been in the oils market for close to 2 decades. We've done a lot of work in it. We've talked to a lot of labs about it. And if you know our previous products and how the kind of improvements that we've made on the oil 7400, you know that we've learned a few lessons along the way. But some of the most important things for this marketplace is cleanliness, is making sure that you contain the oil. So to do that, we have a drip cup that travels under the sample probe. It's built on a camshaft. It simply slides out of the way when the probe goes down, and then whenever the probe is up and it's time to move the arm in the X or Y dimensions, the sample cup will slide back under to ensure that if there are any drips off of the sample probe, they're captured and you don't get cross-contamination. There's a rinse station, of course, with a peristaltic pump to drive it. The rinse parameters are configurable to meet the needs of your specific samples, but with our default settings, we're able to get carryover under 1%. We've seen that very consistently in-house testing and also in our beta sites. And then all of that is over a spill tray. There's a removable spill tray surrounding all the sample positions, and this can hold over 5 liters of liquid. So if you have, for example, you're doing an overnight run, maybe something goes wrong, or you have a spill, or you have an overflow, or you forgot to empty your waste container and now the rinse station overflowed, or you, heaven forbid, accidentally slip and drop a whole tray of samples on the deck, the spill tray will capture that. That's the idea, is these things happen. We know they do. And so what we wanted to do is design a system that can help you maintain the cleanliness of your laboratory. So it serves the spill tray. It's very easy to simply lift the spill tray off of the base. You can take it to a waste container, pour it out, wipe it all down, and put it back on. You're ready to go. And lastly, the system is simple. So it's easy to maintain, right? I mentioned that there's very low consumables. We're touching on that again because the maintenance is almost non-existent on this thing. There's no pipette tips. There's no springs. There's no check valves. There's no weird tees. There's no strange fluidics. It's got very, very simple fluidics. Your probe connects directly to the syringe. Your rinse station is driven by a peristaltic pump. It's about as straightforward as we could make it. It has some of the most intuitive, user-friendly software I've ever seen. It's incredibly easy to use. I'll talk to you a little bit about that in the slides, and I'm actually going to do a demo at the end as well. And lastly, it's self-installable. So this helps users in a couple ways. One is you don't have to pay to have someone come out and do the installation for you. You can do it yourself because of how simple the system is. In addition, of course, there's support available both on email and on phone, and if you really want to have someone come out and install it for you, you can pay for that, but you don't have to. And that's one more way that we're trying to make sure that the cost of this system is going to be affordable for every laboratory in the industry. So I said we're going to talk about the software a little bit. It's very user-friendly. The daily work can begin with about 3 clicks, and customizable methods allow you to adjust for different sample types. Your sequence page, this is where you'd spend most of your time as an operator. It has a very, very simple interface. It has a sequence builder that I'll show you that makes sample setup simple. It's incredibly easy to use. And then once you have your sequences built, it's very, very easy to adjust the existing sequences. So for example, if you normally run a rack of 60 samples at a time on the system, and then you've got your last run of the day where you only have a partial rack, it's very easy to select however many, the last 15 or 23 or whatever it is, samples in your run, you select them all, and then you just tell it to skip them. And basically you can use the exact same sequence. You don't have to create a new one or anything like that. Use the same file. It'll run it through to completion. And then the next time you load that file, it'll be back to just like it was before. It won't save the skips, so it's easy to make adjustments on a daily basis, especially for that kind of the last run of the day. Also, you can add rush samples mid-run. So while you're running, there's an add rush samples button. You click that, it'll finish the dilution it's on, give you a prompt and say, where do you want to put your samples? Your raw samples are here. You want to dilute them into these tubes. You hit go, it'll run those samples immediately, kind of insert them right at the top, run them, and then it will pause again to allow you to take the rush samples with you to go to the ICP, right? And then once you've removed those, you hit start and the system will pick up right where it left off. You can add more samples to the end of a sequence, kind of the same way. And of course, you can queue up several racks at a time. So I think a lot of times people will be running essentially one rack at a time, but if you wanted to really load this thing up and run 240 or 360 samples all in one stretch, you absolutely can. The methods themselves are very simple. I mean, these are all the parameters. We wanted to keep it kind of as simple as we could for the users. So we do, of course, give you control of your rinse and sample parameters. So you're rinsing, the amount of rinse that you use for every sample, how fast you want that to be dispensed, which we found in our testing that kind of the faster the better for both speed and performance of rinsing. That's all customizable to the user, and methods can be designed for different needs and then assigned to specific samples. If you know you have a sample that's going to require a slower sample uptake or additional rinse time, you can specify in your sequence that day for those samples and have kind of your default method, then a deep clean method or that sort of situation. Your dilution factor, I mentioned you can go up to 100x, and there's an optional density correction. Now, we'll talk a little bit more about that when we do the software demo, but it's a nice feature and it's something I'm interested to see how people use it in the marketplace. So this is our kind of your method interface, and it's really simple and fairly straightforward. So now that we've talked about the hardware capabilities, we've talked about the software, I want to go into some of the application data that we have. And I'm going to start with talking about calibration curves. So just like you have to dilute all of your samples before they go on the ICP, you'll need to dilute your calibration standards as well. This does a couple things. One is it serves as a matrix match for your standards and your samples. And the second is that this is a really good way to introduce your internal standard, is you can just put it in your diluent and use the same diluent for everything. And these are both very common within the laboratories. So what we've done here is we made 3 distinct calibration curves. These were all made from the same 4 stock solutions. And all of those solutions were prepared at a 1 to 10 dilution, essentially putting them through the same exact prep that your samples are going to go through. So we used 10, 100, 500, and 1,000 ppm standards. And then what we did is we prepared those by hand, which is the blue lines you can see here on a scale by weight. And then we did it in orange. You have the diluter. And then in gray, we did it again on the diluter. Those are with and without the density correction. And in every case across this wide sweep of elements, we read better than 4 9s across all of the elements in question. And you can see on the graph here, it's clear we're able to get really, really good recoveries across the entire range here, which is good to see. We also did a NIST sample. We actually did a couple. I'm only going to show one of them here. So we did a NIST standard that was prepared alongside a second source QC standard. These are both prepared on the diluter at a 1 to 10 dilution. And all the recoveries within 5% for both our internal QC match and the NIST standard itself. And you can see that the one line's kind of right in the middle. There's a little up and a little down, but everything's within the 5% recoveries, which can be fairly difficult to do, especially with oil samples. And then here's the actual data itself, tabulated with the certified values. That's our recoveries of both the NIST standard and the QC standard on the far right. And again, everything's within 5%. So we're very happy with that. Lastly, we did a series of QC checks, ICV and 9 CCVs that were prepared in sequence with other samples. And then they were analyzed the same way in sequence with other samples in the ICP. So these were kind of spread out, with the idea being that we would be able to see both kind of reproducibility of our sample preparation and also a little bit of a longevity. And what you see here is, again, everything is easily within 5%. There may have been a little bit of drift, but overall the data looks really good. And again, we're happy with that reproducibility of our standard preparation there. Okay, so there's application data. We talked about the software and how easy it is to use. We've talked about the system capabilities. Now I want to get into how this actually kind of fits the laboratory. We know that the wear metals are in service or used oil or oil condition monitoring labs. They vary significantly in their processes. We can't even seem to agree upon a name. So we know that there's a lot of different preferences, and people use different sample tubes and different rack types. And so with that in mind, what we really wanted to do is design a system that would fit the existing workflows and improve them. So rather than making a system and asking you to change your workflow to fit our system, what we've tried to do is create a system that will fit your workflow. That'll be something that's easy to fit into your current workflow and improve it. For a lot of labs, I mentioned before, sample preparation has become a huge bottleneck. And especially given the ICP analysis times, this product, it really does. It removes that bottleneck in an easy and affordable way. And for most laboratories, this system is going to put your prep time shorter than your analysis time, as it should be. And that puts the onus back on your manual preparation steps and the analysis itself. The fact that we have labs, and there's a number of labs that currently are waiting on their diluter before they even start their ICP for the day. And in my mind, as somebody who makes automation products, I think that's backwards. Whatever we can do to really focus our time on the analysis itself is what we should be focused on. So one of the workflow questions, do pour off or not to pour off? Again, some of you are going to know this. You're going to have your solution. I always pour off. I never pour off, right? Immediately off the top of your head. There are other people who probably don't have that answer. So we'll talk about it a little bit. Pour off. What is it? So samples normally arrive in 2 or more commonly 4-ounce bottles. The bottles depend on the lab in question, possibly on the vendor or the customer themselves. I mean, sometimes you get weird samples, but most of the time they come in these 4-ounce bottles. So the pour off is when you actually transfer that sample from a 4-ounce bottle into a sample tube or a sample cup, and then that tube or cup goes on to the either to an analysis or to this sample preparation step, and the bottle goes elsewhere. So why would we do that? Okay, you use an extra tube, you use it, then you've got an extra manual step. And there's a few different reasons. One is you preserve the quality and volume of your raw sample. Then your bottle isn't actually being dipped into by other things, and that can help. There's a concern there about quality. It shouldn't be a big one certainly for this system, but it is something people are occasionally concerned about. I think a lot more commonly, the concern is that they don't want to tie up the sample bottle. If your sample bottle has to sit on the deck for the whole run, how much time is that going to be? And do I need my bottle to go on to other analyses? Things like, do I need my bottle for the particle counter? Do I need my bottle for FTIR? Do I need my bottle for viscosity? Do I need, or is the bottle just going into the next kind of sorting step? Everything goes on the ICP, but then the bottles go off to be sorted into whatever else they have to run. It's a workflow question for the laboratories, but it's important to understand. Another big one really for this diluter in particular is system capacity. So I'm going to use the example here of the Janus type racks or bottle racks that are used on the OE4, OE8 systems. That in that case, you can have a bottle rack that'll hold 32 bottles, or for that same space, you could have 2 of the 96 position tube racks. So the difference between 32 bottles or 192 tubes is pretty significant. Now, in this case, 32 bottles, if you're talking about a 20-second per sample preparation time, you're looking at running that set of bottles in just over 10 minutes. So that's really quick. But essentially, I mean, thinking about that from my standpoint, I'm going, okay, you're going to spend your whole time prepping, constantly capping, uncapping, and moving bottles around just to try and keep up with it. But again, it's a workflow question for the laboratory. So there are people who really want to use bottles, and there are a lot that drive towards this pour-off step. Just important to understand what the need is. Another option for pour-off that I think could be a really good one is that you can pour off once for 2 analyses. So I know this is done in a couple of laboratories where they will pour off for their FTIR analysis, and then they'll actually prepare out of those same tubes. So they'll do their sample preparation for the ICP out of the same tube positions that they want to take to their FTIR, And then after the preparation is done, they take their diluted samples to their ICP, and they take their raw samples over to the FDIR, and they get two preps or two analyses out of a single pour-off step, which can be a really nice economical usage of your sample and your manual time. So whether or not you pour off will determine what racks you use, and they all work on this system. Like I said, we know there are a bunch of different workflows. We want to work with them. So for people who aren't doing a pour-off rack, you're going to be putting bottles directly on the rack. You'll need to use the bottle racks. On the bottom there is a picture of the 45-position CETAC bottle rack. For those that are doing a pour-off step, you're likely going to be diluting out of sample tubes or cups. So the sample tubes, likely you'll be using racks that look similar to the two on the top there. That's the 80 position on the left, the 60 position on the right. Those both use 15 ml tubes. Or you may be diluting or pouring off into cups. So for that, we have these pour-off racks that are specifically designed for pour-off step in oils laboratories that use these little 2 ml cups, and they actually have a catch basin on the bottom and drainage spots between all of the sample tubes. And those work really, really nicely for pour-off for laboratories that are doing that work. Everything pictured here will work on the new diluter. So here's a picture of the sample deck itself, or the tray for the auto sample, excuse me, and it supports a wide range: sample racks, sample tubes, sample cups, sample bottles. Like I said, we try to be flexible and inclusive. So for your sample tubes, you have options of 15 ml or 8 ml across a wide range of metal and plastic rack options, including CETAC racks, including the Janus or OE4, OE8 type racks. Those are all supported on here. Sample bottles, we have the CETAC rack. We also support, again, the Janus racks for your 4-ounce bottles, or for sample cups, you've got your pour-off racks where the 90 position will be supported here. And if you don't see your racks that you want to use on this list, we also have a rack configuration tool that allows you to make a custom rack file to better meet whatever needs you want. So if the software doesn't come preloaded with the combination of racks that you want, or the alignment of racks that you want, or you want to use completely different racks that we don't already know about, if you can secure them to the deck, you should be able to build them into the software. And then the other part of OEM compatibility that always comes up for Teledyne CETAC is OEM compatibility. Who will this work with? And it's a standalone system, right? So there's no need to worry about OEM integration. It will run, or it will prepare samples to be run on any ICP or potentially ICP-MS on the marketplace. Because it's a standalone system, we don't have that hurdle to even worry about, and it can work with just about anybody. And then why would I buy, right? This is always a question. So a couple of reasons that people will look at this system. Obviously, we already talked about removing bottlenecks. We talked about it being a workflow solution. A couple other approaches and why people may be interested in the system is this can be a new system for labs that are still preparing by hand. In both, we have a lower retail price and a low cost of ownership, and the simplicity of the system that may allow medium or smaller labs who previously haven't been able to justify a purchase of a more expensive system to now be able to justify the purchase of our new diluter. Secondly, is a replacement for aging diluters such as the APS 1650. So the 1650 was originally released 15 years ago, as I previously mentioned. A lot of these systems are really getting kind of long in the tooth, and they're getting to a point where they need to be replaced. I know a few years ago when I was working in service, I personally replaced units that were 10 years old at that point, and that was like 3 years ago. So a lot of these units really are, they're getting kind of old, a little bit long in the tooth. Now, I'm not going to say that the 1650 is not a long-lived, robust system, because of course they are. They hold up extraordinarily well over time, but many of them are getting to the point where you may want to upgrade. And if you're looking at currently running a 1650, the fact that you can prepare twice as many samples on what is actually a smaller width, you can save bench space, and you can prepare twice as much on your new auto sampler, that can be a really nice driving factor for getting an upgrade. And lastly, of course, I want you to remember the facts. The system is fast, it's affordable, it's clean, it's capable, and it's simple. With that, I'm going to end the presentation, We're going to move over to the software demo that I promised. For any of you that may have joined a little bit late, I want to make sure that you know if you have any questions, you can submit them at any time. So just if anything comes up, anything from the presentation that you think you want to know more about, please go ahead and submit those. We'll do questions at the end. All right, so this is the Oil-Ease software. When you load up, it'll take you to kind of this main page. This is your sample list page. This is where you'd spend like 99% of the time that you interface with this software. That's where you'll be. And I'm going to show you this splash screen. So when you load the software, what'll come up first is this Oil-Ease. It'll give you a little version information. That comes up for like 3 seconds. I have to show it because I think our marketing guy did a beautiful job, and it's just a lovely splash screen image, and it deserves a little bit of attention. So apologies for the self-indulgence, but it's nice. Also, I want to point out that if you ever need to look for the version information, it's just there in the About, and right next to it is the Help. So if you click on that, that'll open up a separate dialog box where you can go through. It'll have our frequently FAQ is in there, as well as detailed information about everything in the software. So if you have any questions about how anything works, click on the Help, and that's all very easy to use. So normally, like I said, when you open the software, it'll take you to this page. And a typical day, all you would do is open a file, right? And then basically run it. There we go. Sorry, I'm trying to take my time on the software and be a little slow so I make sure that what you're seeing is what I'm seeing. So if there's a little bit of lag and pausing, that's just to essentially allow WebEx to try and catch up to match my screen image. So normally this is all you do, right? You click open, select your file, and then you would hit start, which I can't select right now. It's right in the middle. I can't select it right now because I'm not actually hooked up to an instrument. I'm at home. But essentially that's your daily routine. It's as easy as that for your normal, routine, repeatable work. So that's where you're going to spend most of your time. So I want to kind of set that first and foremost. And then I'm going to take you through some of the other options for the system. So we're going to start on the configuration page. What you'll see here, right at the top left, there's your COM port connections. Once this is done the first time, you should never have to do it. When you do set up, there's a refresh COM port button here that just highlighted. You click on that, the software should automatically recognize where the auto sampler is, and then you just hit connect. And then after that first connection's in place, every time you start the software, it'll remember exactly how it's connected and automatically reconnect. It'll also initialize the system and get everything ready to run. Your peristaltic pump speed is set just below that. We typically recommend 25%. That's the default, and that tends to work really well. And then below that, you've got this lovely sound file. So this is actually a customer request. It's a feature that we had in the previous system software, and something that we actually got a lot of requests to make sure that we include. So the sound file, you're allowed to pick any WAV file that you want for your laboratory. The default is like an alarm sound, but you can pick any WAV file you want. What it'll do is once your dilutions are complete, it'll play you a song to let you know you're across the room or whatever. Hey, this is your notification that this is done. So you should come over and move your samples onto the ICP. They're ready to go to the next step. So that can be a really nice option, and you can customize it to fit the feel and needs of your laboratory, or you can decide not to use it, basically. On the right, you have your set tray layout. So we have this drop-down box, there it is, that essentially all the racks that we expected or knew or could predict that people were going to want to use, we've tried to build in here. So for someone who wants to use directly dilute out of bottles, they would select their 45-position bottle rack or the 32-position bottle racks, and then what rack they're going to dilute into, be it the CETAC 60, CETAC 90, etc. Or for your pour-off racks, maybe diluting out of your 2 ml cups into 90 position. So all those are pre-built, and that's all it is to switch from one to the other. Again, most of the time, once you've got this set up, you're probably not going to mess with it. But I wanted to let you know the options that are there. And then, like I said, if there is something that you don't see in the list that you want to use for your tray layout, there's a custom building tool that I just brought up that essentially allows you to put in the name of your tray layout, what do you want to call it, how many racks do you want it to have, and then you basically just use this map. The white box on the right is actually a coordinate grid that you can use to map out your vials. Essentially, you just center your tubes, build your own alignment file, set your corners on each rack, and then they will populate in the window to the right, so you can actually build your graphical interface right there, and that makes it pretty easy to interact with. And then once you're done setting your tube and tray or rack positions, you set your probe depths and save tray layout. It's all really very simple to do. And once you've done that, it'll go into this same drop-down list. So then you just select it from there without whatever name that you programmed in. So it's a really nice, easy tool to allow for additional customization options. In addition to the configuration, I'm going to show you the manual controls. This is very straightforward. It essentially just allows you to move the probe up and down, the pump on and off, the peristaltic pump. You can prime the rinse station. Then, of course, you have syringe commands on the right. To change the barrel for cleaning, that allows you to put it in kind of a half position, so you can take it off, clean it, and put it back on, or replace it. And then you can initialize and prime the system here. Priming is particularly important. If you change your diluent bottle, you may want to flush out any remaining diluent in the line to make sure that you've got your latest version of diluent with your internal standard. So it's easy to just go ahead and prime that, do 1 or 2 cycles to get it all flushed. Your method, we talked about this, and essentially what you see is identical to what's on the slide. There's not a lot there. You can customize your rinse, you can customize your sample uptake and dispense, but for most people, the default method is going to work extraordinarily well. And then this apply density correction, if you check that box, it'll open up these options where you can put in the density of your standard solution and the density of your diluent. Essentially, what we found is that a lot of labs are preparing their standards at a 1 to 10 by weight, and that doesn't actually mesh with a 1 to 10 by volume terribly well because the densities vary. So if you're doing like 2 mils of standard into a total 20 mils with kerosene, you've actually got significantly more kerosene by volume than you do standard because of the density difference. So this density correction, if you apply that, you can put in the density of your standard and your diluent, assuming that same sort of a 1 to 10 by weight is done elsewhere. This will automatically adjust all of your dilutions to more closely reflect the volumetric dilution of what was done when you prepared your standards. So that may help, should actually help your samples more closely match your standard prep. And then lastly, and like I said, this is where you'll live, the sample list. So right at the top, you've got open, save, save as. That's pretty straightforward. And normally that's what you'll do is open a sequence file and run it. I want to show you this add sample set. So what that does essentially opens up this window that allows you, it's our sequence builder. So what you would do if I wanted to do 90 positions or even 60 positions, right, is you select your starting sample tube. So the orange are your raw samples, ending sample tube. If I just wanted to do 60, okay, so that's the first and last, and you can it'll show you, highlight everything that you've chosen, and then where you want it to dilute it to. For some reason, I want to dilute it into rack 4 here, and then that automatically fills everything out. So it's that simple to put in. Select, here's my 60 samples. Obviously, you can easily change those positioning to change how many samples you're doing. And then down below, you select if you wanted to name it something specific or have it count from a specific number, you can program that in. But the last thing would be make sure you choose your method. And essentially, that's all you have to do is select your starting sample tube, ending sample tube, and your starting diluent tube, and then what method you want. Click the new sample list, and it loads everything out for you. So you can see your final volumes, your exact positioning, your dilution ratio, and all of that. Now, if you needed to go back in and make changes, that's pretty easy to do too. You can select a group of samples by simply clicking and dragging, and then right-click will open up a window. There it goes. That allows you to edit the sample selection. So if you decided, oh, these samples need to use our extra rinse method or a slower sample uptake method, you can change it just for those specific samples or across a group of samples. You can delete the selected samples if you don't want to use those positions, or insert more, or you can skip. So add a skip, allows you to very quickly skip those. You can see the check boxes filled in, and then if you run this solution, essentially when it gets to them, it'll just skip right over those. Of course, if you did that on accident, you can right-click, go back and remove your skips, or if you find that you accidentally miscounted how many tubes you have, because no one ever makes mistakes like that, right? It's very easy to make those adjustments on a day-to-day basis. And you can do all that within your sample list. You can make changes to a new one or, of course, to a saved sequence. All right, I think that about covers it. Oh, I did want to touch on one more thing. So my apologies, all these buttons right at the top, right under where it says unsaved sample list, they're all grayed out, so they might be a little bit difficult to see. The start button's right in the middle, that'll be blue. And so normally when you start your software, once it's running, that'll come grayed out, and then you have to the right of that, you have pause and stop. So your stop is like emergency stop. You click that button, it'll stop whatever it's in the middle of, because probably it's, we've got an overflow or something got in the way, or I forgot to remove a cap, or I didn't put the racks on yet, or whatever, these things happen. So that is stop what you're doing right now. That'll essentially stop the auto sampler, and then when you go to restart or do a next thing, it'll go into a recovery state and reprime the system. Pause allows it to finish the dilution it's in the middle of, and then it will stop. So this allows you to very easily essentially make an alteration to your sequence, make changes, add samples, add an extra rack or any of that without interrupting or ruining any of your dilutions. It allows it to finish the dilution and then pause. You can make changes. And lastly, we have the add rush samples that I mentioned before. That button essentially functions a lot like pause, but takes you through more of a pre-programmed routine specifically for adding in those rush samples. And then the other thing that I wanted to mention here is we've got a status icon. So that will trigger as it goes. The sample in progress will change color, and then once it's finished, it'll turn green. And over on the far right, you have your status message. That'll tell you if everything completed successfully, it'll just say completed. If you run into any errors, it'll tell you what the error was there in the status message. And as you're running, there's a progress bar across the top, right under this 0/60, that will run as it essentially does the sequence. The bar across the top will fill in blue. So if you're across the room and you need to see how close it is to finishing, you can just glance over, and it's a really nice visual indicator of the progress. With that, we'll go ahead and pause. I think that about covers us for the software. I know that was really fast. So again, if you have any questions, please feel free to submit them, and we'll go ahead and move over to those. Okay. So we actually have a fair amount of questions here, which is great. One of these, I guess the first one I want to answer is a question about application notes. So we are working for an application note specific to this system. It's not quite ready for release yet, but it should be very soon. So we'll look forward to that. There'll probably be an e-blast about that. But that'll be a really nice application note that we're doing on our brand new ICP that shows a lot of the data that we talked about here will be presented with our specific methodology and how it was done. We've got how does this system interface with the OEM ICP auto sampler? It actually doesn't interface at all with the ICP. So it's a standalone prep system. After you prepare your samples, then you would transfer the actual rack itself. That gets transferred over to the auto sampler that's on the ICP for sample introduction. So that it's a separate step. Whether compatible with ICAP 7400 Thermo ICP OES. So again, it's kind of the same thing. It doesn't actually attach to the ICP. This is an offline dilution system. So if you have a 7400 ICP, a Thermo ICAP, you can definitely use that, but you would continue to use the auto sampler you have. This prep station would prepare, and then you transfer over. A question here, does this replace the APS 1650? then yes, the APS 1650 will be going away as part of the release of this brand new system. So that will no longer be offered, but we do, of course, have 7 years of coverage continuing on the system after we stop producing it. So we'll still be able to get parts and all of that for the 1650 for quite some time. I think, what are the settings for sample depth, especially for 4-ounce bottles? So the sample depth settings, actually didn't touch on that. That's a good catch. Most of the time you're going to set your sample depth as part of setting up your racks. We have some default values in there already to kind of give you an idea of the right place. But essentially what you'll want to do is set your probe depth so that it goes far enough into your raw sample tube to allow for good aspiration without going like all the way down. So if you were using 15 mil tubes, ideally you'd be pouring them up to a certain height, and then you would try to match the probe to that height and have it just go a few millimeters past the top of the fluid. And then for things like the 4-ounce bottle specifically, that we're still working, there will be a liquid level sensor that'll allow for 4-ounce bottles, but that's still being kind of finalized at this point. And can you import sample information from LIMS? So that's a really good question. It's something that we're working on. It's not in the software right now, but it is part of the engineering project going forward. So there will be, we're looking at CSV, I think CSV and text options for importing and exporting LIMS files. So that isn't an option right now, but it definitely will be in the future. Can samples be cooled on this device? We don't have any plans for that at the moment, but it potentially could be looked into if needed. We could probably work something out with that. And does it use a stir paddle? So we talked about mixing. This is something that's a carryover from the 1650. And actually, I was surprised how very excited many of our customers were by the fact that it doesn't use a stir paddle, because it uses, it just essentially mixes the sample as part of the dispense step. And the testing that we've done with that type of mixing actually show that it mixes significantly better than the stir paddle ever did. It won't use a stir paddle, it just has a single probe, and that's advantageous because it's less electronics, less maintenance, less parts. It's also less piece of equipment or less entering your sample tube, so it can help with carryover. I think there's a couple other questions here that I'll just follow up with you directly on that are a little bit more specific. All right, I think with that, we'll call it for today. Thank you guys so much for attending. Thank you for all your questions. Like I said, I've got a few to follow up on, so I'll follow up with some more of those individually. If you have any additional questions, please feel free to reach out to me directly or to our sales channels. That information is all on the website. And again, thank you so much for your attendance, your attention, and your time. And with that, we'll go ahead and close it.